Hello students. So we were doing complex numbers and quadratic equations, miscellaneous exercise. Okay. Question number 4. If x minus iy is given to be root of a minus ib upon c minus id, then you have to prove that x square plus y square the whole square is equal to a square plus b square upon c square plus d square. Okay. So first you have to remove this root. So this will be x minus squaring both the sides. You will get c minus id. Okay. Now you have to take the conjugate of this. So conjugate of this is x minus iy is a minus ib conjugate upon c minus id conjugate. Okay. Which is a plus ib c plus id, and this is x plus iy the whole square. Okay. This is our property, that is z1 upon z2 the whole bar, that is conjugate, is equal to z1 conjugate upon z2 conjugate. Okay. Now this is x minus iy square, x plus iy square. Now we have given this, we have to prove this, right? We know that if you multiply by its conjugate, okay, so like you will get x square plus y square, correct? But we want square, so we have to square this. Okay, so this will be x plus iy the whole square, x minus iy the whole square, okay, which is our x square plus y square the whole square. So multiply this a minus ib c minus id with a plus ib c minus c plus id. Okay, multiplying by its conjugate, you will get a square plus b square upon c square plus d square. This is what we wanted. Okay. Question 5, you have to convert it into polar form. So first you have to convert this into a plus ib form. So this is 2 minus I the whole square. So squaring, expand it, will get 2 square minus 2 to the 4 I square is minus 1. Okay, on 4 minus 1 3. So multiplying by its conjugate, (28) I square. This is 3 square plus 16. Okay, 3 minus 28, so 25 minus 25. 25 upon 25. So this is minus 1 plus I. Okay. Now you have to write the polar form. So this is x plus iy. Your cos theta is r, you have to find first. Okay. R is 1 square plus 1 square. So this is root 2. Okay. Cos theta x upon r, sin theta x upon r. Okay. 1 upon root 2 means theta is pi by 4. But here cos theta is minus and sin theta is positive. So sin theta positive means this is in the second quadrant. Okay, so this is pi minus theta. You have to do argument of z. Pi minus pi by 4. So you'll get 3 pi by 4. Okay. So polar form is given by z equal to root 2 cos 3 pi by 4 plus I sin 3 pi by 4. Okay. Second one, 1 plus 3i upon 1 minus 2i. So multiplying by its conjugate, we get 1 plus 2i plus 3i minus 6. 1 square plus 4. So 5 minus 5 plus 5i upon 5 minus 1 plus I. Same thing we are getting. Right? Yeah. So the answer will be same. 3 pi by 4. Okay. So you can solve it on your own. Next question. Next question, question number 6. Quadratic equation is given 3x square minus 4x plus 20 by 3 equal to 0. So multiply, first you have to remove this 3. So multiply the whole equation by 3. 9x square 12x plus 20 equal to 0. Okay. Yeah. Can reduce this equation? No. 20 is there and 9 is there. Okay. So we have A, B, C. First you have to find discriminant b square minus 4a into c. 44, 36, 720. So this is minus less than 0. So complex roots. Okay. So x is minus b plus or minus root of 576i upon 2a. Okay. Root of 576 is 24. So 24i upon 8. Okay. So you can take out common here. 6. 6 3 za. So 3. 6 2 za. 4. Okay. Next question. Question 7. Same. You have to find complex roots. First you multiply by 2. Okay. D is b square minus 4 into a into c minus 8. This is minus b plus or minus 8i 2a So 4 to the 1 plus or minus 2i. Okay. No, here this is root of 8. No, this will be 2 to the 2 root 2 upon 2i. Okay. Eighth question. 27x square minus 10x plus 1 equal to 0. Okay. D is b square minus 4 into a into c. X minus of minus 10 plus or minus again 2 root 2y. 2 into 27. Okay, so you can cancel this. 5 upon 27 plus or minus root 2 upon 27. Okay, next question. Same way. D equal to b square a into c. 28 square 40. So this is 6 5 minus. Okay. X is minus b plus or minus root 56i upon 2a. Okay. Root 56 you can reduce further. Mm, root 56 you can write it as 7 8 which is 4 into 2. So 2 root 14. So 2 by 3 plus or minus root 14 upon 21i. Okay. Next question, question number 10. In question 10, is given z1 is 2 minus I, z2 is 1 plus I. We have to find z1 plus z2 plus 1 upon z1 minus z2 plus 1. Okay. So directly you put the values z1 plus z2 plus 1 upon z1 minus z2 means this becomes minus, this becomes minus, plus 1 minus I plus I minus 1 plus 1. So this is 4 upon 2 minus 2i. So you can take 2 common. So 2 upon 1 minus I. And we want it in the form Modulus we have to find, right? So we want it in the form a plus ib. So multiplying by its conjugate, 1 square plus 1 square, 2 plus I, 2 plus 2i upon 2. So 2 gets cancelled. So we'll get 1 plus I. Its conjugate is 1 plus 1, 1 square plus 1 square, so root 2. Okay, let's start question 11. If a plus ib is given x plus 1 the whole square, I the whole square, x square plus 1, you have to prove that a square plus b square x square plus 1 the whole square upon 2x plus 1 the whole square. Now this is again the same thing. A square plus b square, we will get it by multiplying by this conjugate. Right? This conjugate we have to multiply. So if you take the conjugate a minus ib, taking conjugate both the sides, you will get, this is real part. Okay, here no I is there. So you have to take conjugate in this part. Okay, multiplying this, you will get a square plus b square. So you are multiplying this too. X plus I the whole square, x minus I the whole square upon 2x square plus 1 the whole square. Okay, so multiplying this, you will get, this is x plus I into x minus I, again x plus I into x minus I. So this is x square plus 1. The whole square. And this is 2x square plus 1 the whole square. In this it is given, yeah, here it should be x square. Okay, yeah, right. Next question, question 11, question 12. This is 11, right? Z1 is 2 minus I, Z2 is minus 2 plus I. So to find real part of Z1, Z2 upon Z1 bar. Okay, so first you find out Z1, Z2 upon Z1 bar. So 2 minus I into minus 2 plus I upon Z1 bar conjugate 2 plus I. This is minus 4 plus 2I plus 2I minus I square. Minus I square means this is 1 plus 1. Okay. Minus 4 plus 1 is minus 3. 4I upon 2 plus I. Multiply by its conjugate. 6, 3I, 4 plus 1 minus 6 plus 4 minus 2 11i upon 5. Okay, so real part of Z1 Z2 upon Z1 bar is minus 2 by 5. Second, we have to find imaginary part of 1 upon Z1 Z1 bar. Z1 bar. So 1 upon 2 minus I, 2 plus I. So this is 2 square plus 1 square. So 1 upon 5. So there is no imaginary part here. So imaginary part of Z1 bar is 0. Okay. Next question, you have to find modulus and argument. Okay. So first you have to write it in the form a plus ib. Minus 6. So this is minus 1 plus I upon 2. Okay. Mod 1 by 4 plus 1 by 4. So this is 2 by 4, 1 upon root 2. Cos theta x upon 1 upon root 2. So root 2 upon 2, which can be converted into minus 1 upon root 2. Same way sin theta. Sin theta, this is 1 upon root 2. Same way it is the one we had solved. Okay. This is in the second quadrant. Second quadrant pi minus theta. So pi minus pi by 4 you have to do. Argument of z is pi. Pi, that is pi minus pi by 4, which is 3 pi by 4.